Hello everyone, I'm Yujie.
I'm Marcela.
Today we are happy to present our paper, PNEU-SKIN, a haptic social interface using inflatable fabrics. Our research proposed an embodied computational agenda and describes the design and prototyping process of a multisensory smart skin in response to varying social distances. PNEU-SKIN looks into how our clothing could become an adaptive interface to redefine interpersonal communication experience.
Artists have been designing wearables to explore new relationships between body and space for a long time. For example, Ray Kawakubo and Lucy McGrath rethink our perception of the human body by altering the anatomical boundaries of it. As an architectural space, they understand the body as a combination of spaces and structures that can be reconstructed. Technology is allowing us to see our clothing as an extension of our body and also as an interface to interact with our environment. Wearable electronics are becoming everyday objects, and artists, designers, and architects are now crossing disciplines to explore the realm of fashion. Utilizing digital fabrication and electronics, they are proposing new wearables from the point of view of performance, new tectonics, and materiality. However, few projects have explored wearables in the public and social domain and how it can dynamically respond to a wide range of interpersonal distances in social interaction. PNEU-SKIN uses critical making as a research strategy to explore interactive and soft interfaces to create soft boundaries between private and public space. Leslie Kane Weisman affirms the appropriation of use of space are political acts. The kind of spaces we have, don't have, or are denied access to can empower us or render us powerless. The relationship between power and space can be also found in nature. Some animals can inflate their bodies as a visual demonstration of prominence and power. There is no doubt that men dominate the use of public space. In public transport, for example, we often see that the space used by men is considerably more significant than the one used by women. An example of this is manspreading, which is the practice of men sitting in a public transport with legs wide apart, thereby taking up more than one seat. The invasion of personal space is closely related to the study of proxemics, which is the human use of space in interpersonal communication. But what if our skin could respond to the invasion of our personal space, redefining our anatomical perimeter? Will this empower women to reclaim their personal space?
In this project, digital technologies are used to design and fabricate a pneumatic wearable device that reacts to external stimuli through microcontrollers, sensors, and actuators. Utilizing a critical making approach, this wearable acts as a reactive interface between the human body and the surrounding environment, so that the bodily functions can be augmented, enhanced, and expanded. Architects, designers have been taking advantage of digital technology to design more efficiently and reduce costs. However, the critical making approach steps back from this consumer-oriented culture and enables designers to reflect on social implications of the use of technology and practice design as a form of social activism. Therefore, we looked into the theory of proxemics, the most generally agreed taxonomy of human distances in space. According to Edward Hall, indicates that the interpersonal distances of a human are categorized into four distinct zones: intimate, personal, social, and public. These four interpersonal distances have their own uses and characteristics. We then explored ways to enhance human sensory perception and feedback through three types of sensory responses, namely touch, smell, and vision, which were mapped respectively to proxemics interpersonal distance matrix. In this project, we applied an iterative design approach through interactive inflatable prototyping. We developed a critical making agenda and a synthetic workflow with three stages, including material-driven prototyping, parametric design patterning, and pneumatic control and system integration. We explored inflatable fabric module prototype and conceptualized with proxemics-based theory. to develop our sensory feedback mechanism. Through these 3 steps, we achieved the embodied computational agenda through system integration.
We conducted material experiments with inflatable fabric models in different shapes and structures, and testing various sensors and actuators in different sensory modalities. When activated with flowing air, inflatable fabric models inflate and deflate in turn, and models of different shapes and structures demonstrate different characteristics and behaviors. Iterations are made with selected pneumatic performance to achieve desired sensory responses. After cutting the nylon fabric into testing shapes and pleats, 2 nylon layers with 1 connector in between are stuck together with adhesive thermoplastic TPU through heat pressing. An air tube with another connector is then inserted into the air pockets.
We also incorporated distance sensor and touch sensor to detect interpersonal distance and touch behaviors. Responsive LEDs were placed inside air pockets to provide visual cues through color and blinking patterns. In response to interpersonal distance, perfume were also placed between fabric folds to provide olfactory feedback when inflated and deflated with inflatable modules. Parametric design translates 3-dimensional strategies on body surface into a 2-dimensional surface pattern for pattern mapping and laser cutting. Bernoulli patterns were laid out on unfolded surface to accommodate inflatable modules in procedural design software, namely Grasshopper, according to Langer lines, along which skin has minimum tension so that the patterns inform the air pockets and their form transformations. The pneumatic system is primarily controlled by a customized modular hardware platform, the Arduino board, which is developed by MIT Media Lab Tendril Media Group through an Arduino microcontroller in order to control airflow and air pressure. The distance sensor and touch sensor were programmed in response to distance and pressure detection in Arduino IDE. Embedded with sensory technologies and elements, including responsive LEDs, distance and touch sensors, and perfume, PNEU-SKIN achieved original intentions of providing dynamic sensory feedback to varying interpersonal distances.
We laser cut nylon fabric materials for prototyping purposes. The cutting pattern is guided by ergonomic principles. This helps understand the actual material performance and behavior through interactive experiments. The core structure containing the pockets is covered by 2 layers of neoprene, a synthetic rubber sandwich structure textile, and the morphology of this fabric provides stability and maintains the flexibility needed for the wearable. Through pneumatic control, we program and encode how prototyped inflatable models behave and provide sensory responses with simple hinging transformations and texture change in response to different interpersonal distances. The dynamic transformation of the garment can be achieved by controlling inflatable fabrics.
The base layer, facing the skin of the user, covers the pockets, providing support for placing sensors, air pads, and electronics. The front layer was cut out the air pockets to allow them to grow when the air is pumped in. The sensing, pneumatic, and structure layers are assembled by the use of double-sided fusible interfacing, a fusible fleece web that works like a glue when it is heated. The PNEU-SKIN and the human body are finally integrated into a holistic system. PNEU-SKIN presents a critical perspective on current practice and the norms of society. It advocates the critical making agenda and calls on greater awareness of gender inequality, power relationship in space, and other critical social issues in the computational making domain. Architecture is more than just designing buildings and spaces. It embodies the experience of those who occupy them. In this regard, male domination in all spaces is undeniable, including professional, social, and intimate spaces, allowing us to reflect on the role of women in society. Consequently, it is crucial to contextualize architecture in relation to gender issues.
The proposed workflow was developed and tested in design workshop we were instructed in Tongji University in 2018, taught by Benas Farahi and Jifei O. We designed and prototyped a pneumatic wearable that functioned as a haptic social interface that can provide sensory feedback to varying interpersonal distances. Unlike the common task-oriented approach to computational making, PNEU-SKIN goes beyond an investigation of human-computer interaction, soft robotics, and digital fabrication. PNEU-SKIN explored wearables in the neglected public and social domains and how we can dynamically respond to a wide range of interpersonal distances in social interaction.
This is the end of our presentation. Thank you for listening.
Thanks.